Hello everyone, welcome to Taxim tutorial. I'm Zilan, a second-year master student working in RoboTouch lab with Professor Wen Zhinyuan in CMU. I will introduce how to use Taxim, a simulator model for GelSight tactile sensors in this tutorial. Here's the agenda about this tutorial. First, we'll see what is Taxim. Taxim is an example-based simulation model for GelSight tactile sensors. It can simulate both the optical response and marker motions of the GelSight-like vision-based tactile sensors. You can check out our paper for more details about Taxim. We have open-sourced our codebase for Taxim, and we will see how to use codes in later sections. We also have a website for Taxim including supplementary materials, so feel free to check it out. In this section, we'll see how to use Taxim alone. We'll mainly focus on how to install and set up the codes for Taxim, run few provided examples, and then show how to customize Taxim on your own sensor with given codes. In this GitHub repository, we provide 3 pre-calibrated sensor models for first, GelSight sensor manufactured in the lab, second, digit sensor, and GelSight 1.5 sensor from GelSight Inc. For installation, here we first come to the GitHub repository of the Taxim. We have 2 branches. The main branch includes the core Taxim codes. That's where we stay for this section. So to install the Taxim, we follow the instruction of installation on README page. We first clone the codes to a local folder and we install the dependencies. I would recommend to use virtual environments such as Anaconda to manage your packages for different projects. If you didn't see any error messages, then we can move on to run some examples. To run examples, we have provided the code for both optical simulation and marker motion field simulation along with example inputs and outputs. So you can see the section on the README page, optical simulation and marker motion field simulation. So we first have a quick look at the structure of the codes. For the basics include the parameters for the sensor and for the simulation. Feel free to tune these parameters during the simulation. Calibration and data collection, these are used when you want to customize on your own sensor. So we will skip these 2 folders for now. Then under the marker motion simulation and optical simulation, we have main function to call to generate the simulated tactile images. Under the collapse, we have pre-calibrated model for a GelSight sensor, and we will use this during the simulation. And in the end, we have the example data as the inputs and example outputs in the results. Firstly, we run the optical simulation. So we just follow the instruction here to run this command in your terminal. And we see here we are loading the object square and we're running the simulation for a simulation of the tactile images. If you check out the results, here's our Taxim folder and go to the results. We'll see square simulated is just generated today. And these are the simulated tactile images. You can try out the another object as well because we provided both the square and the cylinder 6. We can also try out the marker motion field simulation. So we first exit the current folder and then go into the marker motion field simulation folder. Then we run the same command provided on the README page. And if we go to the result folder, we can see here the square composed and the square height, these are newly generated. And if we check it out, we'll see the marker motion field for X, Y, and Z as our results. And you can always sampling the marker's motion discretely over this marker motion field. The next section is about how to customize Taxim on your own sensor. To do so, we need to first collect some example data and then use them to calibrate the simulation model. In the end, we will run simulation with the new calibrated files. Here, we use a GelSight R1.5 sensor to demonstrate how to collect the data and calibrate the optical simulation model. Here, we have a sphere indenter with 4 mm diameter. We can manually press the indenter on the GelSight surface and save the tactile images with observable sphere indenting. In total, we have around 50 example tactile images, including one background image. Then we use the script generate datapack.py to label the location and the size of the sphere in the tactile images. This will be saved in datapack.mpz file. Given the physical parameters of the sphere, we can extract the normals of each point of the sphere, and then use these to calibrate the polynomial mapping function by running polytape_calib.py. The calibration parameters are saved in polycap.mpz. Then we will see the simulation with our new calibrated files. So we saved our calibration files under the data, and then these are all the images collected from the GelSight R1.5 sensor, and already calibrated with datapack.mpz and polycap.mpz. There are some parameters we can change to have the better simulation quality. So under the basics parameters, we first change the parameter kernel size to a smaller one. And then under the sensor parameters, we adjust the pixel to millimeter according to the new GelSight parameters. And then we change the height to 640 and the width to 480. To do the optical simulation, here we first reload the data folder from our data files, including the datapack.mpz and polycap.mpz. And also we want to reinitialize our simulation to extract the real background. Because we don't have the shadow simulation calibration file, so we set the shadow to false and the init background to false after we init it. Here we see how to run the simulation. Our command is first python simoptical.py, and we load the square object depth as 0.8 mm, and we want to init the simulator. After we run it, we will see our results saved here. So here we see the simulation of square from our GelSight R1.5 sensor. The last part about this tutorial is how to use Taxim within Robot Simulator. We provide the code base in the same GitHub repository but under a different branch called Taxim robot. If we go to the GitHub repository, we'll see the code under the Taxim robot. And this package is an integrated robot simulation framework with Taxim. We show the application of this framework with grasping demos, and the code base is adapted from Facebook's tactile repository. We have provided detailed installation instruction, for example, how to install this package and how to install the dependencies. And also we provide several examples you can run to test out your setup. Some grasping demos with different objects. To customize this simulation framework on your own setup, you should be able to know there are several components included. First is a renderer to simulate tactile readings from a GelSight. This is a part of the Taxim simulation, so you can always calibrate on your own sensor and replace this part. We also have a contact model maps normal forces to indentation depths and shear forces to shear displacements, and there are some tunable parameters. And we have mesh models and URDF files for GelSight, UR5E robot, WSG50 grippers, and different objects. Feel free to use them or replace them. In the end, we provide the examples of grasping, and you can always use this simulation framework for more advanced manipulation tasks. And thank you for attending this tutorial. If you have any questions, please contact me.